This is the June 22nd, 2023 Physics Regents, part B-1. A round dinner plate has a diameter closest to 2 times 10 to the negative 2 meters. No, that's too small. 2 times 10 to the negative first meters, that looks just about right. 2 times 10 to the 0 meter, that's 1 meter, that's way too big. 2 times 10 to the meter, 10 to the first meter, way too big, so it's choice 2. Several springs are lying on a frictionless tabletops with one end attached to a wall, and a variable force F applies to the free end of each spring. The springs have different spring constants K. The diagram below shows the setup for one of the springs. The elongation the springs produced by force F depends on. So, okay, we have the formula F equals K X. So divide both sides by K, you get X equals F over K, which means that X will be directly related to F, but inversely related to K because it's in the bottom. So directly on both, no. It's directly on F and inversely on K, yes, it's that one. Not inversely on F, no. Inversely, no. The table below shows the weight of 4 athletes and the time required for each athlete to run from the base of a hill to its top. What is athlete ran up the hill with the greatest power? So power is equal to work over time, which is equal to force times distance over time. But the distance we can ignore because all of them are traveling the same distance because they're going from the base to the top. So it's basically force divided by time. So we divide each one of these and see which one has the greatest value. So let's see. 600 divided by 11.8, that's 50.8. 650 divided by 10.7, that's 60.7. 700 divided by 10.8, that is 64.8. And 750 divided by 11.9, that is 63.0. So the answer will be choice C. A copper wire carries 2.8 amperes of current. The total amount of charge that passes a point in the wire in 1.3 milliseconds. Okay, so go and use the formula. So we have 2.8 amps of current. We use the formula. Okay, I is equal to delta Q over T, yes. Which means that Q is equal to the current times the time. Which means that the time is 3 milliseconds, equivalent to 1.3 times 10 to the negative 3 multiplied by 2.8 amps, which will give you, let's see, choice 2, I believe. Yes, okay. Next, question 40. The diagram below represents 4 solid copper wire segments at 20 degrees Celsius with different lengths L and cross-sectional areas A. Which 2 segments have the same resistance? Well, resistance is equal to rho, I can't do the symbol, it's the Greek, rho L over A. Oh my god. Okay, whatever. Rho times the length divided by A, which is the cross-sectional area. So the cross-sectional area is 2. So 2, okay. 2 divided by 2, because the length is, if we multiply the length by 2 and the cross-sectional area by 2, that means it'll be 1. Okay? And for this one, if we have multiply the length by 1 divided by 1 is 1. So A and D have to match. So it's choice 4. 2 and 1, that'll be 2. 1 and 2, that'll 2 and no, 2 and 1. This will be 1/2, and then this will be 2. Yeah, so it's only A and D. In substance X, a ray of light with a frequency of 5.09 times 10 to the 14th hertz has a speed of 2.04 times 10 to the 8th meters per second. Substance X could be, so what formula? We use frequency. The ray of light has a frequency of 5.09 times, has a speed of that. Substance X could be, well, we don't need the frequency, that's just to throw you off. Okay, all we have to do is n is equal to the index of refraction is equal to c over v, which means the speed of light is 3.0 times 10 to the 8th meters per second divided by this value, and you should get, let's see, you should get glycerol, which could not be a charge on a particle. Well, the equivalent of a charge on a particle is 1.6 times 10. Oh my god. Okay. Times. Okay, wait. Times. Oh my god. What? 1.6 times 10 to the negative 19 coulombs. So basically, the value which could not be the charge is the one that is not divisible by this value. So 3.2 times 10 to the negative 19 is divisible by this, which means it cannot be. 4.8 times 10 to the negative 19 is divisible, which means it's not that. 4.5 times 10 to the negative 19 coulombs, I believe that is not divisible, so it is choice 2. 6.4 times 10 to the negative 19 is divisible. Which graph best represents the relationship between photon energy and wavelength? Well, the energy of a photon is equal to the Planck's constant times the speed of light divided by the wavelength. Okay, whatever. Wavelength, which means that since it's in the bottom, it's inversely proportional to the energy of a photon, which means it is choice 4. Inversely exponentially, really, yeah. Light travels from air into another medium with an index of refraction of n. The light has a wavelength of 6.0 times 10 to the negative 7 meters in the new medium. Which expression represents the wavelength of this light in air? Light travels from air into another medium with an index of refraction of n. So wait, okay, n2 over 1, which is the same thing as n, is equal to, light has a wavelength in the new medium, travels from air, so which is equal to 6.0 times 10 to the negative 7 meters over, light has a wavelength. Which expression represents the wavelength? Oh yeah, so this is just n actually, and this is what we are trying to find, lambda 2. Okay. Wait, light travels from air into another medium, n2, over, yeah, n, so n over 1 is n, and then light has a wavelength of that in new medium. Yes, and then what is the wavelength of light in air? I believe it's just this. You just cross multiply, that's it. Choice 1. You just have to cross multiply them. Yeah, that was just weird. I believe it's choice 1. If 80 joules of electrical energy is dissipated by a 10 ohm resistor in 2 seconds, the current in the resistor, okay. So 80 joules dissipated by a 10 ohm resistor. 2 seconds, the current. The current. So you could say, resistance times time 20. Well, we could do, let's say, okay, we could use a formula, work equals current squared times resistance times time. Okay, let's just use that. So then work, which is 80, is equal to current squared times resistance, which basically 10 times 2 is 20, so it's 80 equals current squared times 20. 80 divided by 20 is 4, and then the square root of 4 is 2, so the current must be 2 amps. Okay, base your answers to questions 46 and the diagram represents they're the same uniform medium. Okay, which wave has a period that is twice of wave W? Well, the period for wave W is the time it takes for one full wave, so that's the period right there. Which has a period that is twice, so it must be, we have to see a point that is consistent with this. So wave A, no, it has the same. Wave B actually has less. Wave C, yes, it's wave C, because that's the full time it takes one crest and one trough for a full wave, so it's wave C. Which wave is always 180 degrees out of phase with wave W? Well, it basically has to go, if it's 180 degrees out of phase, it's basically going in the opposite direction. So, which one's going in the, A, yeah. A is going in the opposite, it's 180 out of phase. So it's choice 1. Which graph best represents the relationship between acceleration and time for freely falling object? Okay, so it's freely falling, so the acceleration will always be 9.81 regardless of any point in time, because it's in free fall. The velocity will be increasing, but it will still maintain that 9.81 acceleration. So it shouldn't be increasing, it should not be decreasing, it should remain the same because it's in free fall, and it should not be exponentially increasing. The diagram below represents the forces acting on a skydiver with his parachute. So the force of air friction and gravitational force. The total mass of the skydiver with his parachute is 85 kilograms. If the magnitude of the gravitational force is 834, so the force that's bringing him down is 834. And the magnitude of the force of air friction is 652. The acceleration, so, okay. F equals ma. So basically, the net force will be this value subtracted by this value, because it's the sum of forces. So 834 minus 652 is 182. So 182 newtons. Will be 182 newtons down. we could say negative 1 equals the mass, which is 85 kilograms, times the acceleration, which is equal to 85 a. Divide both sides by 85 now. So 182 divided by 85. That will be 2.14 meters per second squared down. Yes. Okay, next, last question of this set. A 15 kilogram air hockey puck sliding on a horizontal surface at a velocity of 7 meters per second north collides with a... Okay, this is a conservation of momentum question. Okay. P before equals P after, which means that what is the momentum before? The momentum before is 15. Okay, we have to convert. Okay, that's tricky. We have to convert grams to kilograms first, which basically means that's 15 grams is, wait, let's check from the reference table. Grams, there's 1,000 grams in a kilogram, so we could say 15 grams times 1 kilogram over 1,000 grams times this velocity, which is 7 meters per second, plus 15 times 15. Okay, 15 divided by 1,000. That is 0.015. So we could just say 0.015 kilograms times 7 meters per second plus 0.015 kilograms times negative 8, because it's going south at negative 8 meters per second, and we just add those up, which means that 0.15 times 7, that is 0.105 kilograms times meters per second, and it's 0.015 times negative 8, which is negative 0.12, so 0.105 minus 0.12. That should give you choice 2, 0.015 kilograms times meters per second south. And that is it for part B1. Next video will be part C.